A lot of times people want to know what is going to work. They're looking to eliminate pathogen propagules from an area. When you look at disinfestants in general, and this is really all of them, they're all broad spectrum, so they all have broad spectrum activity. But all of them have to be applied at a dose that's going to give you that level of control. They require a specified contact time, and there's various environmental and surface factors that will affect efficacy. All of the disinfestants are highly reactive chemicals, and when you apply them, they're immediately reacting not only with the microorganisms, but with the surroundings around them. In those reactions, you're getting a decrease in the dose. So that affects efficacy of these compounds. Also, organisms vary in sensitivity to the different disinfestants. This is very pronounced in research in other areas, such as food handling, medical facilities, water treatment, and there's not really a lot of publications that address plant pathogens, though there are a few. And so I'm going to highlight them here to emphasize this fact. This was a study done with 8 plant pathogens. They used a total of 9 disinfestants, so I'm only reporting 3 here for time, and they're pertinent to compounds that I'm talking about. The way this study was done is they infested a cloth substrate, submerged them for various periods of time, and then plated out a number of substrates, and the percent recovery they translated into a percent efficacy. So I'm reporting the submersion time that was needed for 100% efficacy, and or if they never got it, reporting that at the 60 minutes of submersion time. So with ethanol, you got very consistent results with these 8 fungi. With 5-minute submersions, you got a 100% efficacy, or there was no recovery of these organisms from those substrates. With bleach, you got 100% efficacy against 6 of the genera, but not against the other 2. And with the 6 that you achieved 100% efficacy, it took different periods of submersion or contact time. So with Pythium, a 5-minute contact time, you got 100% mortality. With Rhizoctonia, it took a 60-minute contact time. I've got a quaternary ammonium compound, that's what QAC stands for. The compound used in this study is different than what people would be purchasing currently. Quaternary ammonium compounds vary somewhat in efficacy between compounds, though they generally tend to be similar. And you can see that efficacy, 100% mortality was only achieved with 2 genera. It happened to be 2 common pathogens, Pythium and Rhizoctonia. With the other genera, 60-minute contact time was required. So what this emphasizes is you're using these products with the idea that you're going to get 100% mortality. And you may not be getting 100% mortality. Of course, I'm going to address that issue a little later in the talk. This is another study done in 1972, reported in a Pennsylvania Flower Growers Bulletin. They, in that study, used 7 different genera of pathogen, 6 fungi, 1 bacteria, being the Xanthomonas. Again, they used a range of disinfestants. I'm, again, only reporting 3. This is on the clay pot. Now, clay material is a porous substrate. Not as porous as wood, but it's still a porous substrate. And you can see with the bleach, okay, this study, I'm sorry, it was done differently than the other one. The way this study was done was they used all of these compounds at 1, 2, and 4 times the rate. So even with the Lysol, what they had was a stock solution. 1 times is the label rate. The 2 and 4 times are more concentrated. So there's 4 times the product. And so with bleach, for the most part, a label rate worked. With the case of Slendrocladium, though, it took a 60-minute contact time. And with 2 genera, they didn't get 100% mortality, even with the 60-minute contact time with a 4 times rate. So with the quaternary ammonium compound, again, different than which was used in the other study, the label rate didn't work. They had to use twice the label rate. With 2 of the fungi, they had to go to the full 60-minute contact time. With 4 of the fungi, they didn't get 100% mortality. Now, the way they reported this is either they got 100% or didn't. I'm sure there was a reduction, but they didn't report it in that way, so I can't show that type of data. Lysol actually was fairly effective on the clay, but it still took 2 to 4 times the rate, and it most of the time took a fairly long contact time. This is that same study on plastic, and you can see that both bleach and quaternary ammonium compound is more efficacious on the plastic substrate than the clay substrate. So here with the bleach, pretty much using a one-time rate, with the shorter contact time, getting 100% mortality. Though with fusarium, they still did not get 100% mortality with the 4 times rate and the 60-minute contact time. Again, the quaternary ammonium compound was more efficacious than on the plastic. The Lysol was less efficacious than on the plastic. So what I'm doing here by showing this data is showing you that, yes, disinfestants are broad spectrum, but the dose and contact time is highly relevant whether you're achieving the level of mortality that you're looking for. There is sensitivity between the target organisms, and unfortunately, we really don't have the full comprehensive level of data needed to be able to answer questions to where we can guarantee success with these products. But I do want to emphasize that all of these products do work. And another thing I want to point out is that this same type of information, differences in efficacy with different organism sensitivity, different situations, different environmental conditions, is seen in research in other areas also, whether it's medical facilities, food processing, water treatment. You just don't use these products at one rate and they always get the same level of efficacy against other organisms. So again, the emphasis is to focus on what pathogens we have a problem with, develop information for them. The mention of trade names or commercial products in this presentation is solely for the purpose of providing specific information and does not imply recommendation or endorsement by the U.S. Department of Agriculture. I know for a fact that what I'm doing is presenting information that I've found in peer-reviewed publications primarily. So I'm finding information on specific products. There's more products than that available. A lot of the other products sold by other companies of the same active ingredient are likely to be equally effective. So when I use a name, it's just the name of a product I found in a study. One of the things that I've realized previously and really started to realize to a greater degree when I was putting this presentation together is a lot of this information isn't done in larger scale in-depth research. It's done when a part of the industry has a problem. Often an extension person or a research person does small scale trials. That information ends up getting reported oftentimes in association newsletters, and it's harder to access that information to put together a larger comprehensive summary of the information that would really benefit us. So talking about hydrogen peroxide, just repeating again, it's broad spectrum, active against viruses, bacteria, and fungi. I found literature saying that it has greater activity against gram-positive than gram-negative, though I can find literature showing it's efficacious against gram-negative bacteria. So when I find information like that, I'm not quite sure how to put it in context of our use. But if we look at the label rates, here's a product that is commonly purchased. Again, there may be other companies with similar products, but I found literature reporting this. Xylitol was used at the label rate, achieved 100% mortality with the Labiopsis fascicula on both washed and unwashed plastic plug trays. So we're always hearing that you need to wash these surfaces, and here's a case where it didn't matter. Though I'm going to emphasize in the end that these should be washed. It has been shown to be effective against the organism that causes Fusarium wilt in begonia. In the study with TMB, it caused a reduction in the infective virons. It didn't get it down to being 100% destructive of the virons, but it definitely caused a significant reduction. Here's a human pathogen, and a lot of times I'm throwing in a human pathogen just because really there's a larger literature base relative to human pathogens. So it's just another source of information. These hydrogen peroxides, again, are effective against many human pathogens too. Here's a food processing facility that the study was done. It was effective in eliminating the virus on stainless steel and on lettuce leaf surfaces. One of the things I'd like to point out with hydrogen peroxide is the fact that you have commercial hydrogen peroxides developed for use in agricultural situations, such as the xylitol. They've been labeled, they've been formulated for maximum efficacy. In the study that I'm going to talk about in a minute with botrytis, I included commercial chemical grade hydrogen peroxide in that experiment. You can buy commercial grade hydrogen peroxide, and it's less expensive than these commercial forms of hydrogen peroxide, but the fact is it's not as effective. These commercial products sold for use in agricultural use have been formulated and are considerably more efficacious than going buying a commercial chemical grade of hydrogen peroxide. So the information I'm reporting, these companies have actually done a fairly good job in formulating these products. So while I'm going to show that they don't give 100% control in every situation, the companies are doing a good job in developing these products. Now, when I looked at xylitol and I looked at it on different surfaces, again, I was looking at a dose curve response and then looking at a 99% mortality rate. And with the case of Xylitol, I found that it took higher than the label rate to achieve a 99% mortality with botrytis. With the previous study, that was also found in that study where you were sometimes having to use 2 and 4 times the label rate, and sometimes that wasn't giving you control. So this brings up a question that it is working against many organisms. There's situations it's not. I don't have any more of a clean answer for this than the company will have. This is a product, peroxyacetic acid. It's a related form of hydrogen peroxide. The same company that sells Xylitol has a product with a portion of their product contains this sanitized. I couldn't find as much literature on it, but the literature I found that it was effective against organisms at the label rate. Again, the fusarium wilt of organisms and again some human viruses. And this is again where these products, when you start testing them, they do have good efficacy, but there's really limited literature out there to give us that comprehensive amount of information that we're all wanting to find. Going to quaternary ammoniums, again, it's broad spectrum against fungi, bacteria, viruses. One of the products is Green Shield. Again, there's a number of other products out there that are effective. The literature I was finding listed Green Shield. In this case, I'm looking at the label rate. The label rate of Green Shield resulted in 98% mortality of Phalaeopsis spicicula with a 10-minute submersion of plastic plug trays. In this case, they had been washed previously. It has also give you a high reduction in infective virons of TMV on metal surfaces. Here's again, I'm throwing in a human pathogen. It inactivated a 5-log reduction of salmonella at the label rate. And in this case, the 5-log reduction is a large reduction, so it was very effective against the salmonella. Again, this is a study I did with dose curve response with botrytis on various surfaces. The label rate is 1 tablespoon. And like with the hydrogen peroxide, what I found to get a 99% mortality required higher than the label rate. It would cause the lower rate on galvanized metal. Like the bleach, it was totally ineffective on bare wood. Of the products tested, I didn't mention it or did point it out, as the hydrogen peroxide formulations were the only products that really gave disinfestant control on bare wood products. So this highlights the fact that all of these products can work and are worth using. You're going to find situations that one product may be more efficacious than the other products on the market in specific situations. Now I'm going to mention alcohol. I'm not going to really show a lot of information on alcohol, mainly because I'm not finding a lot of reports of alcohol use for agricultural situations. Again, it is used in other situations, particularly medical. It is a very efficacious product. Where I did find some information relative to plant pathogens, the isopropyl alcohol is more efficacious against bacteria, the ethyl alcohol more efficacious against viruses. Products like Lysol actually include both forms of alcohol along with other disinfestants. There's a number of other products on the market, though I'm not seeing them being marketed for agricultural use. Vicron S is one that is marketed for agricultural use in some of the European countries. You've got a range of disinfestants such as phenolic type compounds, things like chlorophenol and phenolphenol are used in some of the food processing facilities. Some of your polyphenols are used in hand soaps for hand washing. So they have efficacy. I'm not sure why they're not marketed more for agricultural use, though some of these compounds like the iodophores, which is a stabilized form of iodine, are used in some of the animal production facilities, even though we're not using them in some of the plant production facilities. I just point these out for the fact that people should be aware they're out there. It's up to companies to be marketing it. I'm sure some of these products would have definite use in agricultural situations. I'm going to point out vapor producing products. I'm only going to point out one, though I read literature not of ones labeled for agricultural use, but other products other than this one product. So there's, again, a number of products out there. This is a product that produces chlorine dioxide gas. The trade name is Z-Series. It comes in sachets. It can be used to generate chlorine dioxide in water tanks. It's also labeled for use for treating litter in chicken houses. So they're using it in large spaces in a chicken house. Seems to me that that'd be a similar application that may be worth looking into for some of the production systems. She also used for cleaning coil of refrigerator units. Of course, there's the old standby of heat. Heat has been used for a lot of years. As a matter of fact, it was used more in the past than it's probably being used now. Hot water is more for treating plant organs such as corms, tubers, seeds. Typically, you're using temperatures between 104 and 133 degrees Fahrenheit. Steam has used to be used in the past commonly for pots, clay pots, and for soil. It can also be used for potting media. With the older literature specifically, it's easy to find instructions for its use. One of the things I didn't find and I'd like to look into more, and I even actually like to include in a test, is using steam generators, such as some of these applicators used for household use nowadays, and how well they'd work for treating greenhouse benches and polyethylene ground fabric. But I really didn't find literature reporting efficacy for those uses.